Everyone's talking about AI. Is it going to take over your job? Is it going to take over the world? Or is it going to decide humans are not needed anymore? But what actually is AI and what can it do now and what will it be able to do and when will all this happen? My cat Ollie and I will explain this in the series of videos AI without jargon. So why a cat in this video about AI? Well, I've heard people say that cat videos on the internet are the most popular, so maybe that's a bit naive. Perhaps I should be a bit more intelligent about it. But Ollie is pretty intelligent in a general sense, and more of that later. But first of all, let's ask the question, what actually is artificial intelligence? Artificial intelligence is an attempt to make a machine which approximates to a human intelligence in every way. This is quite a good diagram which shows how you can have AI software specific for games like chess or Go, or even driving a car that are designed for the specific area in question, but can't do anything else. So a cat can't play chess, can't play Go, and it can't drive a car. But cats are actually fairly adept at walking around the garden, jumping on hedges and fences, climbing on the roof of our house, doing all sorts of things that actually computer programs or even robots or anything like that don't even have a chance at doing today. Similarly, a baby human today, when they're born, can't drive a car or play chess or Go. But as they grow up, they become more expertise, get more expertise through learning. So the goal of AI is to create something that can not only do things like drive a car and play games, but additionally do everything else that a human can do. All the flexibility and general intelligence that's available to humans. This includes things like common sense and consciousness, which we'll discuss in later videos. And this is really a goal for artificial intelligence, which is quite a few years away. But one thing to note about this diagram is that already for modern artificial intelligences, playing chess or playing Go or even driving cars is already superior to what humans can achieve. And in the longer term, as more and more work is done in artificial intelligence, it will become possible for more and more capabilities to be added. Now, whether or not these are added as each of these narrow intelligences like chess or Go or driving cars, or is it that we can develop an artificial intelligence that has the capability of learning to do anything? And this again is the subject of a future video. Okay, let's look at the cat brain again in comparison with the human brain. You can see from this that it is actually a lot smaller, but what is it about it that makes it less intelligent? Is it the amount of grey matter? One important component of the brain is neurons. In a moment I'll explain what they are, but let's just see how many neurons you've got in the cat and the human brain. We have less than 1 billion neurons in the cat's brain and 100 billion in the human brain, so over 100 times potentially more intelligence. But one problem with that approach is that the African elephant's brain has actually got 257 billion neurons. So some people have said you should divide by the weight of the body because you'd need more brain to control more body basically. But then the problem is that if you take the dolphin, then that has more neurons per mass than the human brain. Now the question is the dolphin more intelligent than humans? And obviously I suspect we're certainly more capable, and we have this ability to have a language and a social community which gives us ability to work together and produce things. So let's stick with the idea of a neuron as the brain's processing unit. Now this is what the concept of neural networks was for artificial intelligence people. What they did was create the idea of a simulated neuron. A neuron is basically simply something that takes in inputs and processes them, and is based on certain previous data and learning, it will decide whether or not to create an output. Then what you do is put the neurons together in a layer and connect them all together to the inputs, and then create multiple layers. In this example, we show Google's TensorFlow Playground, which is open source software and very useful for understanding how neural networks work. Now, the concept of using neural networks has been around for nearly as long as artificial intelligence concepts themselves. But the reality is it's only recently, in fact 2012, when the real breakthroughs with neural networks really happened. And that was because of adding the layers, as I explained. The deeper the layers, the better the neural network. But the problem was that if you had deep layers, you needed more processing power. But at the same time, what happened was people started to use things called GPUs. Now that's jargon, and jargon's not allowed on this video. So let me just explain. A GPU has been used it's like a processor, but it's used for games, and it enables very fast video games to be created. And the way that worked was they were able to do multiple parallel applications, so everything happening at the same time. And this is very similar to what's happening in neural networks, is you've got the neurons all firing and processing their things at the same time. So this breakthrough was a mixture of techniques that were invented and the speeding up and use of these fast parallel computers. And this is really going to happen more and more, and it's going to cause more and more breakthroughs with neural networks. Meanwhile, what happened over those 60 years while neural networks weren't working as well as had been hoped is people used what's called rule-based AI, or nowadays it's actually called good old-fashioned AI. It's just basically a set of rules that says if something happens, then do this. If something different happens, do that. So that's sort of very standard programming type functionality that's done by programmers, and the rules could be held in databases. So AI over the last 60 years has consisted of two approaches. One is machine learning with neural networks, and the other is rule-based AI. Both effectively have a learning component, because even with rule-based AI, the rules could be changed based on the outputs from the users. But generally that could often involve a human and wasn't automatic, although it could have been. So let's try something with Amazon Echo. Alexa, are you intelligent?
I try my best.
And then with the Google equivalent, okay Google, are you intelligent?
I'm pretty smart, but intelligence is like underwear. Important to have, but don't show it off.
So what these are pre-canned responses, and there's probably if I did it a second time it would actually give me different answers. But there are a number of pre-canned responses. That's good old-fashioned AI or rule-based AI. It's not a neural network. But it's actually recognizing my voice and correctly recognizing what I'm saying using a neural network. Generally, as a computer scientist, we don't like to admit that we're using good old-fashioned AI because it's the trendiest thing to say you're using you're using machine learning. So that's the end of this introductory video on what AI is. We're going to spend several weeks on different aspects of artificial intelligence, and I'm going to spend significant time talking about how voice is important in controlling your artificial intelligences. It is the natural user interface for systems, and increasingly it will become the only or the major way that we access computers. We'll also be talking about the effect of AI on jobs, what the future lies, and when these things are going to happen. And I'm also incredibly interested in what actually consciousness is. You hear this term and it's been used for centuries, or in fact millennia. That Plato himself talked about consciousness, and I've got my own views on what consciousness is, and it appears that nearly everybody has their own views, and each person or each group of people have different views, and it's very interesting. Eventually, after we've discovered what consciousness is, we'll move on to cyber enhancement. That's where we add capabilities directly into the brain, but it's similar to what's already happening. We're using our mobile phones today to enhance our capabilities and inform us of what's going on. And cyber enhancement is just direct connections into the brain rather than using your mobile phone. And then we can move on to superintelligence, because as AI gets more capable, eventually the AIs become more intelligent than humans. Already, as we see, they're more clever in specific areas like playing chess, playing the game Go, or even driving cars. And those narrow intelligences are going to increase, and there will be a battle between adding lots of narrow intelligences together to create a super intelligent system, or using the raw capabilities of neural networks to actually create this from scratch and have them learn much more like human babies learn how to live in the world. And then finally, we'll talk about what happens after superintelligence, what the future lies, and when all these things are going to happen. Please subscribe to the YouTube channel, and also you could become a patron using Patreon/AI_, and that would help us a lot to fund the production of these videos. Many thanks from Ollie and myself, and see you next week.